So this is the CAT for 2015. This is day 1, question 2. You can have a go at the question yourself. Just pause the video, have a go at the question. We're asked to factorise. I can see it's a quadratic with 3 terms, so I can tell it's just going to be a double bracket one. Slightly harder to factorise this one because we've got the 3x squared in the front. Factors of 3 are 3 and 1, so obviously one bracket will have a 3x, the other will have a 1x. Now the signs help us. The fact that the back term is positive tells me that both signs are the same, so they're either both plus or both minus. The fact that there's a negative here tells me that both signs will be negative, so that helps us a little bit. Right, now we're looking at factors of 6, so we could have 2 and 3, or 6 and 1. There's lots of different ways you can do this. I find trial and error just as helpful as anything. So let's start. I'm looking at the 11, so I'm going to make an educated guess on this. And actually I know that 3 times 3 is 9, so if we were to put the 3 there, that would give me a 9x. And if I was to put the 2 there, that would give me a 2x. And if they're both negative, that would add to give negative 11x. You get better at it. The more that you try, the more that you practice. You start to get a feel for what numbers look good, what numbers are going to work. But that one there, and of course if you've got time, it's always a really good idea to check by re-expanding back. Oops, minus 2x plus 6. So there's my 3x squared minus 11x plus 6. I got what I wanted. Right, part B. Now here's my parabola graph. Height h of the rope above the ground at a distance of x metres. So there's your metres along there. This is the height. And here's my equation. What is the height above ground of the point on the rope where x equals 2? So if x equals 2, we want to know how high it is. So we'll just substitute x equals 2 into the equation. Now there's no calculator, so we need to do some work by hand. 2 take away 1.5, or 1.5 would be a half. Now 4 times a half, 4 halves, well 2 halves are 1, so 4 halves would be 2, plus 1, h equals 3 metres. Okay, you check that. Right, part C is quite challenging. You might want to pause and have a wee go. For what values of x will y be negative? So what we're saying is, what values of x could I substitute into this right hand side here of the equation, and the number that comes out would be less than 0, a negative number. I'm going to square the x, add 3 times that, subtract 10, I'm getting a negative number. What values of x would that work for? So for example, let's just take something easy like x equals 1. I would get 1 squared plus 3 times 1 minus 10. Now that's definitely less than 0. So x equals 1 would be one possibility. And you might like to try another couple if you're not sure of another way to do it. For example, x equals 0 is an easy one to try. 0 squared plus 3 times 0 minus 10. Negative 10, which is definitely less than 0. So there's another value of x which will make y negative. And you could try some more. Another way to do this, to show off some algebra skills at the same time, would obviously be to factorise this quadratic. Factors of 10, 2 and 5. Just thinking about the graph that would be associated with this equation. If we worked out the y value for lots of x values, I can see when x equals 0, the y value is negative 10, so it cuts down there at negative 10. I can see when x equals 1, if I was to work that out, 4 minus is negative 6, so when x is 1 it's negative 6. For the x-intercepts, where the graph cuts the x-axis, I can see one possibility is negative 5, and the other x-intercept would be at positive 2. And it's a positive parabola, so it's going to be looking like that. And so now if we ask ourselves which x values along the x-axis here, well, I substitute in. I understand if I put 1 in, I get a negative number. Similarly, if I put 0 in, I get a negative number. And obviously any other x value between negative 5 and 2, when I substitute it into that rule, I'm going to get a negative answer plotted. So that tells me that for all x values bigger than negative 5 and less than 2, then y will be negative. Just check that you don't want it actually equaling minus 5 and 2, but at 2 I think the value of that would be 0, and at negative 5, if I substituted negative 5 in, the value would be 0 as well, and we want it negative. So you have a think about that. Right, you need to pause and read the question. Okay, so hopefully you've read it. We've got an equation here. How many weeks n is standing for the number of weeks? Will it take you to reach a goal of walking for 160 minutes a day? So we want to solve when does that equation equal 160. So I can see this is an exponential equation. We could start by dividing by 10, both sides. So 2 to the n minus 1 equals 16. Now hopefully you know some powers of 2. 2 cubed is 8. 2 times 2 times 2. So 2 to the power of 4 is 16. Which means that n minus 1 must be the same as 4. Because 2 to the 4 equals 16, which means n would be, add 1, n would be 5. So, thinking back to the question, the first week she goes for a 10-minute walk each day. Each Monday she doubles the time for which she walks each day. The time for which she walks each day in week n. So if she wants to be walking 160 minutes, if we just think about what's happening here, in the first week she walks for 10 minutes each day, in the second week 20, in the third week 40, fourth week 80, in the fifth week she starts walking 160 minutes a day. So we could say in the fifth week, or similarly at the end of the fourth week. Right, last question, part E. You can pause and have a read of it. We're solving that equation. Tane's had a go at it. Now hopefully, because we have one fraction on the left hand side and one fraction on the right hand side and they equal each other, we can cross multiply, or understand that we're multiplying both sides by 4, so 4 times x squared minus 1 will equal 3 times the quadratic. And just watch the expanding there, that side's correct. That side's correct. Now getting to this side, what we would want to do is we would want to minus 6x, and we'd also want to minus 3, and we'd also want to minus 3x squared, so we can get 0 on one side there. So 4x squared minus 3x squared is 1, I agree with that. Now we wanted to minus 6x, and you can see the mistake in the working there. Mistake. We've got negative 4 there, and we're minusing another 3, which would be minus 7, so that's correct. Explain Tane's mistake. Well, there's the first mistake, and what we'll do is we'll just correct it now, so it should be x squared minus 6x minus 7. Let's carry on with the problem. 7 and 1. Negative 7 plus 1 would give me minus 6, or negative 6. So solving that gives me positive 7, or negative 1. Now it might be a good idea in this instance to check both solutions. It's always a good idea, especially when you have a denominator. So if we put x equals 7, we'll get 7 squared is 49 minus 1 over 49 plus 2 times 7 is 14 plus 1, and we want that of course to equal 3/4, so let's have a look. 49 plus 1 would be 50, so that would be 64. Dividing them both by 8. Let's take it a bit slower. Let's divide them both by 2 first. Now we can divide them both by 8. 3/4, which is what we wanted. Let's try substituting x equals negative 1. So negative 1 squared is 1, so we get 1 minus 1 on the top line. The bottom line, negative 1 squared is 1, plus 2 times negative 1 would be negative 2, plus 1, so let's try that. 1 plus 1 is 2 minus 2 is 0. Now we have problems. So it's not 3 over 4, and the other thing is you should never divide by 0, because that gives an undefined function. So the only solution is x equals 7, which means the teacher is correct. And just make sure that the mistake is there, that you've mentioned what the mistake is.